Welcome to section 11.9, Solving Radical Equations. This is video number 2. In this video, we are going to be dealing with square roots on both sides of the equation, as well as the concept of extraneous solutions. So essentially, solutions that do not work. So sometimes we end up getting those and we just have to deal with them, and that is why we check our work. So make sure you're doing that every single time you do a problem. So here we go. Here's our first concept we're dealing with, solving radical equations with square roots on both sides. We have the square root of x plus 1 is equal to the square root of 3. What's nice about solving radical equations with square roots on both sides is we can take that concept of squaring something on both sides and actually get rid of our radical entirely, which is really nice and makes things really, really clean. So let's do just that. Let's square our radicals on both sides. So if we were to do that on the left-hand side, all we get is x plus 1. That squared undoes the square root. Those cancel each other out. And the same sort of thing happens over here on the left-hand side, where essentially our square root and our squared number cancel each other out, so we just get 3. After that, we can subtract 1 from both sides, and we end up with x is equal to 2. Now let's check and make sure our solution works with our original equation. Our original equation, we had the square root of x plus 1 is equal to the square root of 3. So let's add our x in there, and our x we decided was 2 after we solved it. So 2 plus 1 is equal to 3, so our square root of 3 is equal to the square root of 3, and that is perfect, and that's exactly what we want to see. Our next problem here, we have the square root of x plus 8 minus the square root of 3x is equal to 0. So if we were to take the square root of both sides, so if we were to, if we were to take the square root of both sides, or squared both sides, it wouldn't really help us in all reality. It's going to make this whole thing right here really messy, because we'd have to do the FOIL method, and it could get really hairy, and I don't even want to think about it. It's actually adding a lot more work to our problem. So instead, what we are going to do is this. We are going to enjoy the fact that this says minus the square root of 3x. So that means we'd essentially add square root of 3x to both sides, and we're just a little bit more finished, and we can essentially do the square root or square both sides and end up having success. So we have the square root of x plus 8 is equal to the square root of 3x after we do that, and then from there we can square both sides of our equation. So we end up simply with x plus 8 is equal to 3x. From there, let's actually do a little bit of math work. We are going to subtract x from both sides so we can get our x's on one side and all of our numbers on the other. And we simply have x is equal to 3x minus x, which is equal to 2x. We're then going to divide by 2, and we get 4 is equal to x. So let's actually check and see if this works with our original equation. So we want this square root of 8, or square root of x plus 8 minus the square root of 3x. We want all of that to become 0 after we do a little bit of our math work. So let's give ourselves a little bit more room. So we have the square root of 4 plus 8 minus the square root of 3 times 4 is equal to 0. Square root of 4 plus 8 is the square root of 12 minus square root of 3 times 4, which is the square root of 12. 12 minus the square root of 12, that'll equal 0. So 0 is equal to 0, and that is awesome. It checks out. It works. So do subtract something first before you start squaring both sides. Now here is my disclaimer message. Caution, be careful of extraneous solutions. So squaring both sides of an equation may result in an extraneous solution. That is a number that is not a solution of the original equation. The reason why this happens is essentially when we square both sides, we know when we take the square root of that, we will get a positive and negative answer, period. When we take the square root of something, we should get a positive and negative answer. Now, I know I've said focus on the positive, let's look on the bright side. In all reality, we can't always do that. We need to make sure that both the positive and the negative are solutions to something, and if they are not, then we need to make sure we say that our only answer is a specific one. So, let's understand what this means. If I have x equals 3, there's an answer that I received, an x equals 3. That means, in all reality, I should be able to square both sides, so I get x squared is equal to 3 squared, so that equals x squared equals 9. If I were then taking the square root of both of those numbers, I then get x is equal to the square root of 9, so x could equal positive or negative 3. Now, we know from our original statement, x was equal to 3. It does not equal negative 3. So negative 3 is an extraneous solution. So as a rule, you always need to check your work. As well, if for some reason you got that negative 3 was your only answer, you end up with a situation where you have no solutions. So let's play around with this concept of extraneous solutions. Here is our equation here. We have the square root of 6 minus x is equal to x. So what we're going to do at first is square both sides. So we get 6 minus x on the left-hand side, and then on the right-hand side we get x squared. So now in all reality we have a quadratic equation. So let's add x, and we're going to subtract 6 from both sides, and we'll end up getting 0 is equal to x squared plus x minus 6. Bottoms up, we love it so much, so we got to do a little bit of bottoms up. Our first term times our last term is negative 6. Our middle term is a positive 1. It's over 1 on each side. What two numbers add or subtract to get us a 6, or multiply to get us a negative 6, but it'll add to get us a 1. So a positive 3 and a negative 2 would. So 0 is equal to x plus 3 and x minus 2. So x plus 3 is equal to 0 and x minus 2 is equal to 0 based on that zero product property. So x can equal negative 3 and x can equal a positive 2. Those are our two solutions. Let's see which one works, or if both of them work. So we need to check our work. We need to say 6, or the square root of 6 minus, let's do our first one, of negative 3, minus a negative 3 is equal to negative 3. So 6 minus a negative 3, square root of 6 minus a negative 3 equals 9, which is equal to negative 3. So the square root of 9 is equal to 3, so minus 3 cannot equal negative 3. Doesn't work. So this negative 3 is not an answer. Let's make sure this x equals 2 is an answer. So same thing as before. We're going to check our work. We have the square root of 6 minus x is equal to x. So for those x's, we're going to put in our 2. So we have 6 minus 2 is equal to 2. So 6 minus 2 is equal to 4. So we have the square root of 4, which is equal to 2. Square root of 4 is equal to 2 every time, so 2 is equal to 2. That checks out. X equals 2 is a solution. So I hope I didn't get us too confused. Let's practice one other problem and see how this all works yet again. So as always, we are still going to check our work and make sure everything works out well. We have 11 plus the square root of 5x is equal to 6. So let's start out by subtracting 11, so then we can take the square root on both sides. If we subtract 11, we get the square root of 5x is equal to 6 minus 11, which is negative 5. We can then square both sides, and we get 5x is equal to negative 5 squared is a positive 25. And then from there we're going to divide by 5 on both sides, and we get x is equal to 5. Let's see if this works. If we get x is equal to 5 and it works in our equation, that means it's an actual answer. But if not, it means we don't have any solutions for this problem. So we have 11 plus the square root of 5 times 5, which is equal to 6. 11 plus the square root of 5 times 5, which is 25, is equal to 6. The square root of 25, if we were to do that math, we get 5. So then we have 11 plus 5 is equal to 6. Equal to 6. And 11 plus 5, if we did that, we get 16 is equal to 6. 16's never equal to 6. They look kind of similar, but they're not the same thing. They're never equal to 6, so x cannot equal 5. That means there are no solutions to this problem. So if you end up with extraneous solutions and you cannot find an answer, then sadly there is no answer to this problem. So practice a couple of these problems. We'll do some more in class, and hopefully with the homework you'll get it. Thank you very much for listening, and I will see you later.